Hello everyone, this is our final group presentation about the class of INS 5546. And now I'm going to answer the several questions in part 11 in our group assignment. So first one is, what are the new and alternative hypotheses that the project 2 is testing? When it comes to this, the new hypothesis is it's null, its return is equal to 0. That means that there is no significant differences in returns between the long portfolio and the short portfolio of the stocks sorted by a specific characteristic. This implies that the characteristic does not have a predictive power for stock returns. Another one is alternative return hypothesis, that is, return is not equal to 0. There is a significant differences in returns between the long portfolio and the short portfolio of stocks sorted by a specific characteristic. This implies that the characteristic does not have predictive power for stock returns. So when it comes to the question 2, what is the methodology of the portfolio construction and how is it implemented in Project 2 code base? First part is construction method. In this specific code, to build the AS portfolio, we do the following steps. First is ETL. That means extract, transform, and load. The main purpose of ETL is to extract the data from the number of different data sources, clean and transform this data to meet analysis needs, and finally load them to the into the centralized system, the dictionary in our project for analysis. Use the read BRCS with this function to extract the adjusted closing price for the specific stock symbol within the defined data range from the CSV file of the stock price information and collate it into the panel sequence. Using the daily return calculation this function, we did calculate the daily return from the price information rate. Using the monthly return calculation this function, we calculate the monthly return from the price of information. Finally, the adjusted redictionary function, this function, which is used to summarize the previous two reports into the dictionary. The second part is calculate volatility. Volatility is calculated by analyzing a stock's past price movements, in this case based on past daily closing prices. Calculating historical volatility involves finding the standard deviation of the price return and may be adjusted to annualize volatility as needed. In the code, the specific calculation process. The volatility calculation is function when the change name the parameter is set to vol calculates the monthly volatility using the standard deviation of the closing price of the ETL result. The monthly volatility calculated in the previous stock is then combined with the monthly return using the merge tables this function, organize it into a table to facilitate the portfolio construction. And then the third step is build LOS portfolio. A long short portfolio is constructed by going long the last quantity of stocks and short the first quantity of stocks in each month. The specific steps in the code are stock ranking, The specific method is to divide stocks into two quantities. Each stock is assigned a ranking based on the quantity in which its characteristic value is located. This step is implemented in the code through stock sorting this function. Construct a LI's portfolio. According to the groups, each month give long the stocks in last quantity and short stocks in the first quantity to build LS portfolio. Calculated returns. The monthly return of the LS portfolio is calculated by the DF calculation, this function. So now moving on to the question 3. Inferences from the output of the part 9. So from the output of part 9, we can draw following inferences. Average return of the long portfolio. The average return of the long short portfolio indicates whether the characteristic used for sorting. For example, volatility is effective in predicting future stock returns. A positive average return suggests that the quantity stocks of the stocks outperform the bottom quantity. This statistics of the long short portfolio is the statistic measures the statistical significance of the average return of the long short portfolio. The high T statistic typically greater than 2 just that the returns are significantly different from 0, providing evidence against the null hypothesis. So the question 4, reliability of the results. There are 3 parts of this question. First one is data quality. The accuracy and the completeness of the stock return data and the characteristic calculations are crucial. Only missing or incorrect data can affect the results. Simple. And now let's come to the part 2. Simple period. The chosen sample period. The chosen sample period should be long enough to capture different market conditions. Short sample periods might not provide robust results. On the third part 1, backtesting bias. The methodology should avoid the look-ahead bias and data snooping bias, ensuring that the characteristic calculation only uses the information available at the time is critical. Before the question 5, there is another thing I would like to talk about is robustness checks. Performing robustness checks such as using different sample periods, characteristics, and quantity thresholds can help validate the results. Given these considerations, the results can be considered reliable if the methodology is sound, the data quality is high, and the results are robust across different scenarios. So let's talk about the last question, question 5, further work based on project 2. Based on this project, the following to-do list outlines further work. First is explain the characteristics, that is, to test additional stock characteristics such as momentum, size, value, etc. See if they also predict the returns. Extended sample period, just like using a longer sample period to capture different market cycles and improve the robustness of the results. Out of sample testing, that is to implement all of the sample testing to validate the predictive power of the characteristics in different time periods. And then the cross-validation. Use cross-validation techniques to ensure the stability and reliability of the portfolio construction methodology. Besides, risk adjustment is very important, which is useful at adjusting the portfolio returns for factors such as market data, market beta, size and value to see if the characteristic provides abnormal returns at this alpha. And then that which should also consider transaction costs. And that just like you imagine that incorporate transaction costs on a liquidity constraints to understand the practical implementation and profitability of the strategy. Under such under these conditions, we also need to consider that with the development of technology, automation and scalability is very important in stock markets. This is to this is used for developing a more automated and scalable framework for the analysis to handle larger data sets on more frequent updates. What's more, with the equipment of artificial intelligence, machine learning could help us to explore all machine learning could help us to explore and to identify and predict stock turns based on the combination of characteristics. By pursuing these further works, the project can be expanded to provide more comprehensive and reliable insights into stock return predictability and portfolio construction. So that's what we are going to talk about, and that's all our answers to those questions in part 11. Thanks for everyone's participation on their effort.